Okay, today I'm going to share with you why you will fail to learn TDD. Okay, and I will do it because I honestly believe that the great love stories come from the way that you overcome those challenges, those difficulties, those misconceptions. So this is not a code-driven talk. You can't even expect that I come here trying to teach you TDD. If that is what you were thinking about, you still have time to find another room. I will not take that personally. However, if you decide to stay, what we will do here today is a story-based talk. I will tell you the story of what will happen once you decide to learn TDD. All those challenges that you will face and what you can do to overcome those. So, in the same way that the Portuguese princess, the Catarina de Bragança, brought the love of tea to the Brits, I want to be the Portuguese guy bringing you the love of TDD. Kind of the same thing. My name is Gui, and I'm not here trying to sell you my YouTube channel or a book or a workshop. I'm not even here trying to tell you that I have a course on DomeTrain with 20% discount. I would never do that, right? I'm just here because I know that if you want to learn TDD nowadays, it will be quite challenging because you will find yourself in the middle of an angry discussion with a lot of snobs behind a laptop on Reddit, on Twitter, discussing about this topic. And in one side, you will find those who really love it. And they will tell you things like this. This is the best thing ever, you just don't get it. It's your problem, okay? This is the best thing ever. And that recalls me about my dog. When he was a puppy and I tried to teach him a new trick, if he didn't get it, I would think, yeah, maybe it's a problem of him. It's not me that is failing as a teacher, okay? It's just not that type of dog that gets everything at first. It's kind of like putting the shame on the other side, right? There's almost an innate feeling against those that don't write code in the same way that you do. And I could find so many reasons to hate people, but the way that they write code is not one of them. So, in the other side, you will find those who basically are against TDD. And they usually will say things like this: it's just a waste of time, okay? They are skeptical about it. And in this camp, I find two types of people. One of them usually don't write code. They will be a manager. They will be, for example, your product team. And I get it why they don't like TDD, because as it says in the Bible, in the beginning God created the heavens and the earth, and then God said, let's keep tests. It's the only way to achieve a deadline, we know that. And if you are used to use this thing to have a negotiation with developers, and now you can't have it because they say that they need to write tests before the code, what can you do? Someone is moving your cheese. And you also have those that, in fact, they tried to learn TDD, but things went wrong. Things didn't went the way that they liked. They say that they experienced things like this, like tests became too hard to maintain, or the structure was too coupled on those tests. It was hard to refactor them. The development cycle was too slow. And also, often that was because they were writing tests that didn't bring a lot of value. Okay? And I get all of those critics. Okay? But it's about those that we are here today to try to address those. And I honestly believe that often when you have two opposite sides on a discussion like this, often the truth lies in the middle, right? To me, TDD is not the best thing ever, but also is not the worst thing ever. Okay? It's a tool that you can apply in some cases, and it might be quite useful. So let me tell you my story, how I got into TDD. I used to work at a company where we had a lot of unrealistic deadlines, okay? You might know the feeling. And there was one day, at the time my wife was expecting our daughter, and it was a Friday. You know that you should deliver software on Fridays, right? So we done that as it should be. And we had a deadline on that Friday. And in the morning, things were going wrong. So we decided to stay late on that day. We pushed through, and I skipped dinner. I had to call my wife saying, I'm not going home for dinner today. Eventually, we managed to put everything together. We ran some smoke tests. We deployed everything. So I went home. I was walking home. It was night. It was cold, the Portuguese cold, not the British cold. And I recall seeing people joining together nearby the restaurants to go out. And the only thing that I could think of was getting home, sitting on my sofa and watching TV just to relax. But when I was approaching my car, I got a phone call. And on that moment, I knew that I was going home to fix a problem, not to relax. And this would not be a huge problem if this didn't happen so often. And when it happens so often, you need to do something. And I tried many things, like end-to-end tests and all those things. But I was reading this book that is Test-Driven Development by Example by Kent Beck. And I decided to try it. And at first, it was hard. I didn't get most of the things, to be honest. But with the time, I finally got it. And it was extremely challenging because I didn't have a mentor, someone who used to practice it, that was side by side with me, telling me, go this way or react in this way, in this case. So I had to learn a lot of things in the hardest way. And now I know that TDD might not be a silver bullet. It doesn't solve all those problems that I was facing. However, there's one thing that is true. It's really transformative. I'm not saying this just because most of TDD practitioners say the same thing. You will often listen to them saying things like, TDD changed me, TDD is amazing, and I'm now a different type of developer. But they usually don't go one step further, saying, how that thing could change you, how are you different now? And the way that I like to describe it is, I'm not an amazing developer. Okay? The best developers that I've met during my career, they don't practice TDD, and they are still awesome. But TDD was the thing that created a habit that made me step up in my career, okay? That made me a better developer. So I was someone that needed a framework, a way of working to get there. Others don't need it, and I get it. So you might now ask, why someone like me might say that this thing changed me and others really hate it? How is that possible? The way that I like to describe it is with the Gartner hype cycle. Not sure if you are familiar, but it says that the adoption of a technology usually goes through this kind of shape, where at first you are really excited about it, right? It's amazing, this is the best thing ever. Then you will start facing challenges and you will get stuck here, on this place. And here is the moment where most will stop doing it. They will stop here, they will not push through, they will quit, and they will hate it. Okay? This is the moment. The other ones that say that it's transformative, they will say that they went through the slope of enlightenment. That is basically, I learned the hard lessons to learn, and now I feel that I'm better. I can build something better with this. So my goal here today is to help you that once you start your journey, when you get into there, how to get out of there. Or ideally, how you don't go there either, okay? So if you want to get into this journey, and if you want to know where this amazing place is, come ask me after. If you want to come on this journey, one thing I can assure you, it will be hard, okay? It will take time. Can I ask everyone a favor? Can you please interlock your fingers? Come on, okay? And now close your palms. Now, please do it in the other way. Doesn't it feel uncomfortable? Yeah? For some of you, it might not be, but for most of us, it is. You might find the same thing when you cross your arms. When we are so used to do something in the same way every single day, doing something in the opposite direction, it will not feel natural. And the same thing happens with code. Usually, I don't know anyone who learned to code by writing a test first, right? We write the Hello World program. So when you do that for such a long time, eventually it might be hard. But once you start practicing it over and over again, you will see that it will be quite easy to do it in both ways. So, at first, when you start your journey, you will start with the famous red-green refactoring. And no, this is not a mistake that I paint every single thing in green. This is simply because of the fact that I'm aware of the power of suggestion that says that if I show you a lot of green, on the way out, you will take the best decision, okay? Psychology has studied that, so I think it will work. So the red-green refactoring is that magical cycle that takes you through small increments to achieve that thing. But there's a lot of things missing here, in my opinion. There's a lot of hidden rules or misunderstood rules. And one of them is the fact that I think that, in fact, someone forgot something here. There's a moment that it's not reflected here, but if you read that book that I told you, it's there. Kent Beck talks about that quite often, but I don't see many people practicing it. That is a moment of thinking, a thinking phase. Now, that thinking phase, we call it the test list. And what it is the test list? The test list is, it can be a pen and paper, it can be a notepad file that you have in your computer, it can be a code comment, pick your tool. And what you will do with this thing is to offload every single thing that comes to your mind when you start working on something. Okay? If you have an idea for a requirement, write it down. If you have an idea of something that might fail because of a third-party dependency that might be down, write it down. Okay? Something that can be a test should go here first. And why do you do that? I'm not sure if you are familiar with the concept of getting things done by David Allen. That is a productivity methodology for managing your life. And according to David Allen, there's one first step that is putting everything out of your brain. Okay? It says that mind like water. Why? Our brain isn't made to hold a lot of information. It's made to take decisions, to process information. And it's a known fact that we can't hold a lot of things in your head. So if we keep storing those things in your head, eventually we'll forget something. So if you start creating the habit of writing down every single thing that comes to your mind during the cycle, it will help you a lot. So you can see TDD as getting things done for developers. Not only is getting things done for developers, is also an excellent way to practice the Yagni principle that everyone says, right? The you ain't gonna need it, or the KISS principle as well, keep it simple, right? You will see that playing out during the cycle. And why it is so important to have this thinking phase? Because once you type every single thing in that page, taking the decision of what's the next test will be quite easy. Do you know the blank page syndrome that if you are writing a book, you will face it eventually? Developers sometimes feel the same when practicing TDD, knowing what's the best test to write next. And sometimes we don't take the best decision. The decision should be looking into that list and trying to find the next test that is a small step, but still makes progress. Okay? That's your goal. Once you find that one, you will write that as a failing test. Don't write all of them as a failing test at first. The goal is to take it one step at a time. Just that. TDD is not inverting the waterfall. Okay? It's one step at a time still. The other thing that you will struggle with is that if you use a typed language and you are so comfortable with your IntelliSense, you will notice that it's quite painful to write a failing test against code that doesn't exist. And eventually you will take one decision, that is, let me go to the place where I imagine that the code will live, and I will create a class there, and I will create a method, and then I write the test. Because then I have the IntelliSense, and that is what I want. But this moment is the moment where you daydream, where you design the developer experience that you would love to use. And once you took that decision of doing it first, now what happens is that naturally, we don't want to get back there to rename something when it doesn't feel right. And I find that pain of typing every single thing, character by character, is quite informative. So don't rush things. Type every single thing by hand, and then use your refactoring tools to generate that code. Do it that way. The other thing that eventually will happen is we get so used to this cycle, and it's so obvious that if you just created a test, it should fail, that eventually you stop running the test in the failing stage. That will happen. And it doesn't seem like a big deal until the day that you think that a test was written correctly, but it was not. And it happens more often than we might think. That's one of the reasons why I'm not in love with the idea of testing after, because I can't trust any test that I've never seen him failing, because I might have written it in the wrong way. So one thing that you need to make sure is that every single time that you are writing a new test, you will always run it to see it failing. You might have written the assertion in the incorrect way. Your previous step might have been too big, okay? And that is information that is useful when practicing TDD. So now you have your test failing. Let's take it to green. And take it to green is one of the steps where I see that is most challenging, especially to developers with a lot of experience. Why? If you start learning TDD, you will see that most of the tutorials will take you to a lot of dumb steps. The classic example is creating a method to sum two numbers, right? So you want to sum 2 plus 2, so you'll write a test that is sum 2 plus 2 should be equal to 4. And then the implementation will be first, let's return a constant with 4, then I will replace that constant with two constants that are 2, right? 2 plus 2, and then I replace those 2's by the arguments, okay? That's the typical process. And when you start doing that over and over again, that's boring, that takes a lot of time, so eventually you will believe that TDD is painful, it takes a lot of time. But why should we do that when it's quite clear that summing two numbers is just putting two variables together? Why doing that? So the thing that you should do is that if it's quite obvious to you, just do it. No need to do a lot of dumb steps when it's just a matter of doing it. The other thing that developers tend to struggle with is when they start doing this type of approach, if you have a lot of experience, your natural tendency is to start designing every single thing once you try to take it to green. But the goal is not that one, okay? When doing TDD, Ian Cooper has an excellent metaphor that I like, that is, when you are doing TDD, you need to think about it like driving stick shift. You need to observe what your code is telling you. You need to react to it. You need to apply different strategies to different problems. For example, are you feeling confident that you know the solution? Just type it. Things are going wrong? So let's roll back to the dumb steps, okay? So TDD is also being mindful of what your code is telling you. So the other thing that I wanted to tell you on this stage is, I think it's better with a story. I used to work with a developer. Let's call him José, just because I love the way that the Brits say José Mourinho, the Portuguese coach. So I think it's a good name. So José was a developer that you will recognize him because you have worked with someone like him for sure. He didn't read books about programming or blog posts. He didn't be extremely enthusiastic of coming to a conference like this one. I think that if you ask him nowadays who's Nick Shapsas, he will tell you that is likely someone from Hollywood or something like that. He was not aware of what is happening. And no one in the team liked to work with him because most of his code was copy-pasted from Stack Overflow. However, oddly enough, the management team and product team loved him. How's that possible? Because he was always the first coming back with questions. He was always the first exploring the things and trying to put something together to show to the client. So I can't believe that I'm going to say this at a conference, but be like him, be a duct tape programmer. Okay? When taking your code from red to green, don't be afraid of copying from Stack Overflow, ChatGPT, GitHub Copilot, whatever. It doesn't matter. Your goal is just one. is every single thing inside of a single method to take that test to green. Because we will start thinking about how to make that good code, how to fix those scenes in the next step. That is the famous refactoring. So refactoring is one of those that developers tend to have different relationships with it. We all have that experience of trying to do a huge refactoring, right? And everything goes wrong. So with TDD, we do it quite often. But even then, many developers, when practicing TDD, they tend to start with it, and eventually they skip it. They leave it to the end. Okay? They just start rushing it. And I get it, because in theory, refactoring is an optional step, but take it as optional in the sense that I might change some things, I might not. But I will always ask the question, do I need to change something? Okay? Always look at the code and try to understand if there's something to improve. Sometimes you might be happy on how things are going. Other times you might look at it and you think, okay, in the next iteration, I might find something useful that will guide my solution. But always ask the question, because your goal here is quite simple, is to make that code good. Some like to call it clean code. I like to call it simple code. Okay, call it whatever you want. Apply the team conventions, improve readability, remove duplication, do all those things here. But please promise me that you don't do it just for the code. You need to do it for the tests as well. Otherwise, what will happen is that eventually you can't keep up with your tests. They become too hard to read, too hard to maintain. And we usually forget about those. And last but not least, there's one extremely important step, that is, don't have tests here. If you are in the refactoring stage, it's not a moment to have tests. Martin Fowler says that refactoring is that moment where you improve the internal structure of your code, but you don't change the external behavior of your code. And that is also an excellent definition of what a test should be. A test should be something that checks the external behavior of your code, not the implementation details. So if in refactoring you only improve the inside, why adding a new test? In theory, we are not adding a new behavior.
I can help with that if you turn off airplane.
Oh, thanks, Siri. Never thought to have a sidekick during a talk. The next thing that you'll start doing once you master that cycle is look into things like this, the testing pyramid, right? Quite famous, but you will eventually start complaining that you have a lot of duplication, and developers don't like duplication, right? We are told that that's not a good thing. So you start seeing that you have tests on end-to-end that are covering every single thing from the unit as well, right? So you go online and everyone is telling one thing. You shouldn't do a pyramid. You should do this thing, a diamond, right? You should write your tests against a public contract like a REST API and plug your dependencies all and, for example, your databases and everything and test that way. Simple. That way, you don't need to deal with mocks. Cool, I like that, right? You don't need to write as many tests. I like that as well. However, if you practice TDD, that test suite will start taking a lot of time to run. And it will be a bit harder to maintain those tests because they share something. And when you share something in tests, things become tricky. And 10 seconds to run a test suite might not seem a lot, but for someone that practices TDD, is the reason to stop running them, to running the tests. So eventually, you either quit or you get back to first principles, okay? The testing pyramid. There's nothing wrong about this pyramid besides naming. And we know how hard is naming in software development. And when we talk about unit and integration, they are the best example of failing to name things in software development, in my opinion. For example, I don't know any good definition of what a unit test is, but this is a brilliant definition of what a unit test is not. According to Michael Feathers, a unit test is not something that will touch a database, that will go through the network, that will touch the file system. Okay? In other words, it's something that runs in a perfect isolated bubble. It's isolated from the outside world. And how can you put that together when many architectures have a business logic layer where most logic is there, depending on the data access layer? How can you do that?
What if the database can run in memory?
If the database runs in memory, that way you are basically running a fake. So you can still do it. We'll get there. What you need to do on this case is to start thinking about architecting for testing. It's one of the most important features of a good architecture, and we tend to ignore those. Often we pick an architecture based on the number of folders or the way that they are structured, but we shouldn't do that. The famous example is clean architecture. Everyone knows it. Everyone either loves it or hates it. But we often forget to decide that that architecture is designed for testability. Like clean architecture, you have onion architecture, or my favorite one that is in the root of all of those, and it's so much simpler, that is hexagonal architecture, or also known as ports and adapters. And the thing that I want you to get from here is not the fact that this thing is an hexagon. It's the fact that this thing has all the logic that your application has inside of that box, that white box. Just that, okay? Clean and onion on all of those follow the same model, but they have things on top of it, basically that. And what this architecture defends that your application is basically a sum of three things. One is, most of the things that you need to do will live inside of the core of your application, okay? That is that white box. Then, no application lives without touching the outside, right? So you need to define some contracts with the outside world. To those, we call them ports. Once you have ports, you can plug in things, right? When someone invented the power grid, we didn't thought about charging our mobile phone, right? But the system has ports for that. That's the way that you design your system. And once you start doing that, those small things that will connect to those contracts are simply translation layers from your perfect isolated bubble, that is that white thing, with the outside. For example, do you need to write something into a database? Quite simple. Just plug in a new adapter that might be a single class, sometimes a single method that translates an object into a transact script, right? It can be something as simple as that. And once you have this structure in place, once you have this architecture in place, now it's quite easy to map it to the famous pyramid. And this is the type of rule that might be extremely helpful for you. For example, how do I do it? Once you have your core of application, now you know that inside of that thing, you will not have code that depends on a database, on the network, on the file system. So you have unit tests. Okay? As that question, what if I'm using an in-memory database? An in-memory database is something that can act as a test double. Okay? A test double is something that I can plug into one of those ports to simulate something. So it's still a unit test. So you will test 90% of your code through that, through unit tests. Quite fast, independent, perfect. Then, adapters. How do you test those? How can I be sure that I write the correct thing into the database in the correct way? Right? You need to test that as well. So to that you use integration tests. And some might not agree with this definition of integration tests, and I get it, but integration is the integration between two systems. It doesn't mean that you need to retest all of your logic of your application plus the integration with another system. Okay? So what you can do is to simply simulate the code through that contract that you defined somewhere here, and you go directly to that adapter and test it with integration tests. Start a container or something like that and run those. Then you need something to be pretty sure that once you deploy this thing, it will go through. It will not fail spectacularly once you run everything. So you need to make sure that everything is well configured. You can plug all the adapters into the core and it works fine. To those I call application tests, but you can use any type of end-to-end functional whatever tests you usually use, okay? It's something that you build your application and you run kind of like a smoke test on top of it. Just one or two basic scenarios to make sure that everything is okay. If you have this in place, now you might think, OK, let me test drive every single thing here, right? The answer is no. TDD is not for everything. That's another common misconception. TDD is not for everything. TDD is not for those end-to-end tests. TDD is not for driving the user experience of an UI. TDD is not for something like a spike. Okay? TDD is excellent to build this thing right down here. It's excellent for that. But it's not the best tool for the rest. Okay? Knowing that is extremely important, because otherwise you might be wasting that time that many complain about it. With all of that in place, you will eventually get into a moment where you might think, OK, Gui told me that I shouldn't run TDD on the end-to-end tests, but there's one thing that a lot of people talk about, that is ATDD, acceptance test-driven development. And that is a kind of like an end-to-end test. What about those? Good question. For those that don't know, ATDD, or acceptance test-driven development, is an idea that you come up with a DSL, a domain-specific language, with your clients, and your client will work on the tests. They will write the tests and maintain them for you. Never seen that happen. Yeah. So if we've never seen that happening, why doing it? Why wasting time doing that? What you should work with your clients is to define the acceptance criteria. Once you have those, you can put them as an acceptance test if you still want, but in a language that you master. You don't need translations between them. It's painful, those given when then in natural language translations into C# or Java or JavaScript or whatever. Those are quite painful. So why doing it? Why wasting time? The other example that is quite similar is BDD. BDD by Dan North. It's an excellent idea if we ignore every single thing that came after the name. BDD at first was basically, it came from a simple idea. Dan North realized that if he comes to his clients and said, instead of saying you should practice TDD, he said you should practice behavior-driven development, developers would write better tests. Because now they realize that this is not about the test, it's about the behavior that we are asserting. Right? So the name is perfect. But then we come up with those business languages like, and things like Cucumber and Gherkin and all of that. And I think that those don't help. Okay? Those don't bring you a lot of value. So in a nutshell, do not do ATDD. Okay? It's my opinion. Once you start doing all this, one thing that you eventually will do is be extremely proud of test coverage, right? If you are test driving, you have an excellent coverage. So why not targeting 100% or 90% or something like that, having a goal to keep the bar somewhere, okay? Most teams try to do that, right? At least usually 70 to 80%. And that seems like a good goal to have, but it's not. That is basically lying to you, okay? Coverage doesn't mean a lot. It's a metric. It's a signal that you can observe to see, I'm not testing everything in this area of my application. I should invest some time here. So it's a signal. But if you don't use that in combination with other things like, for example, the number of bugs that you have, or the lead time, or velocity, all those things, it's useless. If you want to use something that really brings a lot of value to you as a developer, is in fact mutation testing. Mutation testing is a practice that can give you information about the quality of your tests, in fact. Okay? It's quite simple to do it. And it will give you a score, and you can check, OK, I usually don't test these type of things, and I'm wasting something with it. So there's something that you can learn with mutation testing. Then eventually, you will come into a place where everything that you have done seems good, you are happy with it, but things will go wrong just because you want to add a new feature. Just because on that day you had to do a refactoring to accumulate something new. And you'll see a lot of red tests. And those red tests might be scary, and you will realize that you need to throw away a lot of them. And once you do that, you will start questioning the value of TDD. or the value of writing automation tests, because that was the promise. I could refactor everything without having to throw away those tests, right? So this is the moment where we are on that curve that I showed you, and we stop doing it. And this is the moment where you can persist and get back to first principles and overcome the challenges. And the things that I will tell you next will be quite useful to you if you practice TDD or not. Even if you are practicing test after, if you pay attention to those, it will pay off. The first one is that you will realize that we have a natural tendency to lean into this idea. If we have a new test when we have a new method. Okay? There's a natural tendency for that. Even though in that rule that I showed you on the refactoring stage, right, that you should not have tests there, there's a natural tendency to do that. But that is false. What you should be paying attention as a reason to create a new test is when you have a new behavior. Okay? New behavior is something that adds a new functionality to your application. That means that you will often have that test testing code that you just took to green, so it's all a mess inside of a single method or something like that. And you start working on that, and you need to adjust it, right? So you decide to refactor it and extract an internal method or something like that. So you do something like this. You have a new test, you enable somehow to access those internals, and you test that. And it seems a good idea, right? But this causes a lot of problem because now your tests are coupled to the implementation itself. Okay? Now it will be hard to refactor that code. Okay? And you are not respecting that idea of what is the refactoring stage that Martin Fowler told us. The other thing that you might do in this case is, okay, I don't want to extract a single method. This is too complex. It's like a mapper or something like that. And what I want to do on this case is to extract, in fact, another class. I will extract a class with a method inside. Okay? That's my idea. So what you do is that, let me extract that method into a new class. Let me test it. Okay? Sounds good. And now you start thinking, how do I keep the test inside on the top running, right? And usually what you will do is that you will put an interface here or something like that, right? And then you will mock it, and you can keep up that test. So then you spend a lot of time programming expectations of that mock to simulate the thing that was here, that in fact was just a mapper. And there's no need for that. Okay? You can do this in a quite simple way. So instead of abusing, from those mocks and interfaces, you can use the real thing. If it doesn't touch something from the outside world, like the database, the network, and all those things, you don't need to do it. If it's a database or network system, something like that, you can still use a mock and extract it somehow. And often you will notice that we have a natural tendency to have things like interfaces in some types of languages, just for the sake of testing. Okay? You have kind of like a one-to-one class by interface, and that is not helpful. So in a nutshell, all those samples that I showed you is the idea that you should test behaviors instead of implementation details. And why and how? You will test those behaviors always through the public contract. What is the public contract? It's not REST API, don't think about that. It's the public boundary of your module. Okay, you have kind of like a library or a package, whatever. It's the public boundary. So if we think about that hexagon, is those contracts that we talked about. Okay, you will test through those. And why do you do that? Because we know that contracts are stable, right? It's quite easy to keep them stable, but the implementation details are something that might change. It's not might change. By definition, we should be able to change them whatever, in the way that we want, right? So refactoring is that, and we should be able to refactor as often as we want. So that's the basic idea. The thing that I wanted to ask you now is just for one small thing for help me. Can I ask for an applause for motivation purposes? Thank you. Notice that I asked for an applause. I didn't tell you who should start, the frequency, the velocity. I didn't tell who should hand. I didn't told the position. I didn't tell any of those. I just told you one simple thing. I told you the what instead of the how. But we usually try to test in the other way, like this method should be called X number of times. This should be called first and the other one. Okay? There's a natural tendency to do that, especially when we come from the habit of creating tests after, that they tend to be a bit more biased since we look into the implementation and then write a test to that. And there's a natural tendency to do that. So once you get all of that, what I can tell you is that you still will struggle, especially when you get back to office, right? And you will listen to some people saying, okay, TDD slow us down. And you might feel that that is not fair, especially because eventually you'll realize this thing that I noticed, and many say exactly the same thing. Once you start practicing TDD, the time that you used to spend running the debugger goes away, and now you do it through tests that will live forever. I go months without starting the debugger of my applications, right? Months. And that is a lot of time that we usually use. You can figure out that when you play something and then you go with the mouse and you check, okay, something's wrong, let me fix it. Start again. Those cycles now are converted into tests, and that is extremely valuable. If even then you feel the backlash from your teams, from your team leads, from your product team, my advice to you is that it's better to ask for forgiveness than to ask for permission. Okay? If you come by and say, I think I should write tests first, everyone will shut down your idea. But if TDD is the way that you feel more productive, why shouldn't you do it? I've never seen anyone being fired for doing an excellent job. Okay? I usually act in a way that if I was the owner of the company, it would be the decision that I would take, okay? So I'm doing the best that I can, that I believe that is the best solution, okay? If someone has something against it, okay, let's have a discussion. Let's see why. Let's exchange points of view. But my first reaction is always, do I believe that this is the best thing? Am I the most productive in this way? So why not doing it that way? If you do that, you will realize that TDD is a flywheel. A flywheel is a mechanical device that requires a lot of energy to start spinning, but once it's spinning, it doesn't need a lot of energy. It conserves the momentum. And TDD acts exactly the same way. In the beginning, it will be quite hard, extremely hard. But then, small increments will keep it spinning. And small things will bring a lot of good things. A test might prevent a bug, and if you do that quite often and you improve the design, eventually things start flowing better. You have less things in the backlog that are just a pain, right? And your clients start to be happy because they see you delivering value and they don't call you as often with a problem. So all of that brings good things. So I know that the best world would be you would be in a team where everyone would be doing it, but you can still do it alone. Okay? I have done that and it works as well. After all of that, what I can assure you is that if you go through that slope of enlightenment, you will eventually feel that you are test infected. That is that feeling that you can't write code without writing a test first. That's when you see a pull request and there's no test there, you feel nervous and you need to do something about it, okay? And that's a good thing. That's a good thing, but it doesn't stop there. Let me get back to the story of my dog. His name is Feijão. And when he was a puppy, taking him for a walk, which was quite painful, he will pull the leash, he will jump, he will bark, he will try to run, he will try to hunt butterflies, he will try to eat poop, as dogs do. And I tried to help him and fix that, but I couldn't do it. Eventually, it became really a problem. So I asked for help, and turns out there's some people that they are not dog trainers, they are behavioral specialists for dogs. Okay? Not sure if you are aware of that. And in a single class, everything changed. And it was not him that changed. It was me. I learned that to teach, I need to observe, I need to listen, I need to have empathy, and I can't shut it down with ideas like, you just don't get it. He taught me all of that until 2 weeks ago, when he passed away due to cancer. But till the last time, I learned a lot of things with him. And what I wanted to challenge you is that once you go out there, not only you change your life, but you have some empathy with others and try to see their point of view as well. Thank you e obrigado.